Okay, so here's the last problem in section 5.2, the orthocenter on a coordinate plane. So we remember that the orthocenter is found by finding the perpendicular altitudes to each line. So each line or side of a triangle. So what I'll do is I will draw those in different colors. So this one will be our green one right here. Let me use a thicker pen. So this one will be our green one. And we can have a blue line right here. And remember, each line has to be perpendicular. It's just a line that goes from one vertex and is perpendicular to the other side. This guy goes from one vertex and is perpendicular to the other side, or truthfully, or the line containing that side. And then we have this guy over here, this red line. So what we need to do is find the equation of each line to figure out how they intersect. Fortunately for us, they treated us very kindly by having this green line. Hopefully you recognize that this green line is a vertical line. All vertical lines have the equation x equals. Because if you notice, any point on this line has a value for the x coordinate of 1. X equals 1 here, x equals 1 here, x equals 1 here, forever and ever. So the easy equation to come up with is x equals 1. And not a whole lot of work needs to be done there. Now these other guys are going to require a little bit of work, so I'm going to ask you to remember a few things. Do you remember the point slope form of a line? Y minus y sub 1 is equal to m times the quantity of x minus x of 1, where m is the slope and x sub 1, y sub 1 is a point on the line. This is like an easy way to get the equation of a line without doing a whole lot of work. So we're going to do this one instead of using slope-intercept form like we did last time. So if I'm going to do that, another bit of information I need you to know is if I have a slope of a line and it's equal to, let's say, a over b, the slope of a line that is perpendicular to it would be opposite reciprocal, negative b over a. So this relationship is what we need to exploit in order to find the slope of these lines. Use the point to find the equation of the line. So let's go ahead and get started with the red one. So I know that the equation of this line will be perpendicular to this line by definition, right, of altitude. So what I'm going to do is find the slope of this line. Change in y over change in x. So for the red equation, I first find the slope of this segment. So I get 4 minus a minus 2 over negative 2 minus 1, which gives me 6 over negative 3, which gives me a slope of negative 2. Now, the perpendicular slope, this line that is perpendicular, we will change the sign. So instead of negative, it'll be positive. And then we'll take the reciprocal of 2. 2 being 2 over 1, we'll make this slope 1/2. And that is the slope of the red line. Okay, so now that that's done, we have a very short work of just finding the equation. We're going to just say y minus, again, we're dealing with this red line, the y value, 4, is equal to the slope, 1/2, x minus the x value, which is 4. So this is the equation of the red line. I know it's not in the form you like. We can manipulate it and make it look different, but this is a legitimate form of the equation. Now let's check out this blue one. So the blue equation is perpendicular. The blue line is perpendicular to this segment here. So I got to first find that slope, change in y over change in x. So I have 4 minus a minus 2 over 4 minus 1. When I calculate that, I have 6 over 3, which gives me a positive 2. Therefore, my perpendicular slope that I'm dealing with, the slope of the line that's perpendicular to it, is going to be negative, change the sign, and take the reciprocal. So it's negative 1/2. And so now that equation, y minus, let's get the y term, 4, is equal to slope negative 1/2 times x minus the x term. When I subtract a negative 2, it really is adding that 2. So this is the equation I have for the blue line. So now what I would do is I would use systems of linear equations. Now we can graph those, right? Or we could use substitution method or elimination method to find the intersection point. But the cool thing is this guy right here, let me not do that in blue, this right here, this green equation is pretty simple. It's x equals 1. So whatever point falls on this line, right, whatever point falls on this line, it must have an x coordinate of 1. So I can I can skip the systems of linear equations work that we would do, and I can use the fact that I already have one variable solved for. So if I plug 1 into the equation for x, I should be able to find y. And so let's do that for the red equation, just for kicks and giggles. Y minus 4 is equal to 1/2 x 1 minus 4. So notice I put my x value in there, and now I'm going to calculate y. So I'll distribute this after I do what's in parentheses. 1 minus 4 is a -3. So I have -3/2. Are you with me? And then the next thing I'm going to do is move this over to the other side. So I'm isolating y. And then so what I end up having is y is equal to +4 minus 3/2. If you remember that 3/2 is 1.5, 4 minus 1.5 is going to be 2.5 or 2.5. Okay, a little bit of fraction work there. So we get 2.5 as the y value, and that kind of looks right. 2.5, like right in the middle there. And so just because we're going to be efficient, awesome mathematicians, let's go ahead and check it in the other equation, shall we? Let's check it in the blue. So I'm going to take y minus 4, let it equal -1/2, 1 plus 2, right? Plugging the 1 in for x. And when I do that, I get that y minus 4 is equal to a -3/2. See, 2 plus 1 is 3, times 1/2 is a -3/2. When I move this over to the other side, you're seeing it. We're getting exactly the same thing, +4 plus 4, and y is therefore equal to 4 plus 4 minus 3/2, because it still is negative, which is equal to 2.5, as we talked about before. So the point, the orthocenter, is going to be found at 1, 2.5. All right. I know that that was a little bit tricky because it kind of reminded us of a lot of old algebra that we needed to do, but I think it was worth it. Let me know if you're having trouble with that, because it is something that, that we may have forgotten. Let's take a look at a grand overview of some of the concepts that we talked about, because these things can be confusing. So if you look, when you have perpendicular bisectors, now perpendicular bisectors are perpendicular and they bisect a side. They do not necessarily go through a point, right? They don't necessarily go through a vertex. Perpendicular bisectors, you can have 3 of them. When you do all 3 of them within a triangle, you get the circumcenter. And the circumcenter is the meeting of all the perpendicular bisectors, all right? And then the special property is that the circumcenter is equidistant from the vertex. So once I find this point, that point on the line where I got all the perpendicular bisectors, that point is going to be the circumcenter, and it'll be equidistant from each of the vertices. Angle bisector. So if angle bisector cuts each angle in half, and I would do that here as well and here as well. And when I do that, they fit in a line. They have a common point. They have the point, it's called the incenter. And the incenter has the characteristic that the distance from that point is equidistant from each side of the triangle. The median, I know it's all confusing because it's like, what? But the median, try to hold on to these. The median goes from the vertex to the center of one of the opposite sides. So the medians meet in a point called the centroid, and the centroid has that 2/3 property where BR is going to be 2/3 of BD, or we can say RD is 1/3 of BD, and that's the same for all of these. So the shorter side is going to be 1/3 of the whole thing, and the longer side is going to be 2/3. The altitude, which we just talked about, gives us the orthocenter. The orthocenter, the lines containing the altitudes are concurrent at an orthocenter S. And they didn't give us a real property for this. I don't know that it's super special or what it does, but that's our lesson in a nutshell for the past 2 lessons. So I hope that this is clear. Let's see. Oh, so now that you've worked so hard to do all of those problems, or to read through and to listen to me do all those problems, you get an opportunity to work on them yourself. So here we have just, what I printed out for your packet. You're finding different values based on the information. So you've got medians, angle bisectors, and altitudes. And this may not go into all of the details that we just talked about, but at least it gives you a good foundation of what's going on. And they ask us a little bit about the orthocenter, centroid, and circumcenter. And this is a little bit more challenging, but I think you guys can handle that. All right. So for now, I'm going to ask that you try to work on that, and let me know if there's some way that I can give you assistance. Please take care. I look forward to seeing you guys in the near future. God willing. Take care. Bye-bye.